So I find these types of questions difficult, partly because you end up with too many variables here, or at least my approach here. So let's start with this. A beats car B by 45 kilometers, which means reaches the end. Let's say that distance is D, which is what we need. B is here, so that A is 45 kilometers ahead. So I'll label the rates as R sub A, R sub B, and R sub C for these three cars. And so the first relationship is RA times T1, which is the distance covered by car A minus that of B, same time, is 45. We also know that D is R sub A times T1. That's the total distance covered. And I'll then translate these other relationships as well. B reaches here, C is here, 50 kilometers. So we'll have a similar setup. RB, now the time will be different, minus R sub C T2, and that's 50. And then finally we also have A. That means C would be somewhere here, and that distance is 90 kilometers. And in this case, the time stays as T1 because this is the time at which A reaches the end of the race. So that would be RAT1 minus RCT1, and that's 90. So you can see too many variables here can be confusing. We also have D is RBT2. So my goal is now to get to D, get rid of these variables. So the first thing I'm going to do is to replace these with D. This is D. So let's see if that helps. 45. D minus RCT2 is 50. Maybe some students will do this directly, but at some point you have to recognize that that equation also holds true. RAT1 is equal to RBT2. So I notice here that I can get rid of T2 from this, and I can plug that in. Actually, do I want to plug it in here? Actually, I can take these two and equate them to each other. So that would be D minus 45 over RB. I'm really isolating T1. And then from this, it's D minus 90 over R sub C. So that's 1. And I'll create this ratio here. Now I have this equation. And then I have T2 is D over RB. And from this, T2 is D minus 50 over R sub C. So you'll see RB over RC would be D over D minus 50. And you can see that these two are equal. So it is a hard question because, I mean, imagine doing this under time and pressure. And maybe I've made it harder by having too many variables, perhaps. But this is kind of how I can implement all this work consistently under exam conditions. It's still a difficult problem. Now, others are going to approach it differently, and that's fine. You just have to make sure you can do it consistently under test conditions. And so here, let's see, I have to cross multiply, which would become, because when I actually first did it, I didn't have the cross multiplication, but, well, so maybe I didn't split it differently. So this would be D square minus 50D minus 45D. So maybe I'll get the wrong answer, but we'll see. Equal to D square minus 90D. That drops out. This is minus 95. That comes here, will become 5D. 10, and I get 450, which is choice A. I think my original work, let's see, yeah, it's right here. You'll see that I didn't get a quadratic here. So clearly, you know, there are slight differences. Even though I just did it, I forgot how I actually combined the equation. So be prepared for that. When you have such a mess of an equation, it's easy to get entangled. And so in the exam, I'll probably leave this towards the end. But make sure that you have these, you can set up in a fashion that works for you and can do the algebra to get to what you need. And perhaps there is a conceptual way of doing it, It's just something I cannot implement consistently. So figure that out if that appeals to you. But to summarize here, the answer is A.